Today is February 7th, 2016. For my listeners, check it out. 50 cents at a garage sale. Not too bad. If you want to get good books, go to garage sales, go to thrift stores, go to library book sales. You can find a lot of good stuff. On page 227, something really stands out to me. A whole philosophy stands out against what I've been working on. But it really stands out when you understand the time scales of the philosophy I'm trying to teach versus what everybody, gets conditioned into in school. I'll go ahead and read this out to you. Origin of magma. Based on available scientific evidence, the Earth's crust and mantle are composed primarily of solid rock. Further, although the outer core is in a fluid state, this material is very dense and remains deep within the Earth. What then is the source of magma that produces the Earth's volcanic activity? Notice, they want to know what is the source of the heated rock. On page 228, what is the heat source to melt rock? They ask it again. One source is the heat liberated during the decay of radioactive elements that are thought to be concentrated in the upper mantle and crust. Workers in underground mines have long recognized that temperatures increase with depth. And they go over, pressure and temperature. But that's given. It's already hot down there, and it's already very high pressures. Where does the magma come from then? The problem is their philosophy, the way they look at the world. They want to view the Earth as being somewhat of a perpetually working system with their plate tectonics theory and the fact that the crust recycles itself, which is, I don't think it's very sound theory, to be honest. Plate tectonics was invented before they actually understood, what was going on, and they could, figure the Earth out. But what happens is when you look at the Earth as a giant ball, the geologists, they say, well, it's uniformitarianism. It takes things very, very long periods of time to change. So if we see the Earth the way it is now, chances are in the very beginning, when it was forming, it was the same size. It was the same everything almost, except for maybe the outer crust was a little bit more magma related. And it had a thin atmosphere when it was formed too. So big Earth, thin atmosphere, and everything just changed slowly immediately after it formed, exactly the way it is, and it's been this way for billions of years. But that leads to the question of where does the magma come from up in the air still? And realize that there's a very, very rich history to the Earth that didn't exactly have the Earth forming as is, which is the assumption that geologists make. The question, where does the heat come from, needs to be looked at from a larger scale of time. In the theory I'm developing, the heat came from the birthing of the star itself, which is, a dissipative event from galaxy birth, when the quasar is born. And all that material is ejected from the central quasar, forming billions of stars. And those stars cool and eject and mix with the other stars, and they cool. Some of the new ones mix with the old ones, some of the old ones mix with the even older ones, and they form systems out of that. And they mix like a giant hurricane of stars. And some continue mixing, leading to the result that some very young stars should adopt to very, very old stars, such as the Earth and the Sun system. And intermediate age stars as well, such as Jupiter, Saturn, Neptune, and Uranus, which are still evolving. And that brings another point. Astronomers and astrophysicists and geophysicists and geologists, they don't look at Earth from an evolutionary standpoint. They look at it from a uniformitarianism standpoint, where everything was like this in the past and it's always been like this. Not from a catastrophism standpoint. I don't think that's a good way of looking at it. I don't think uniformitarianism is a good way of looking at it. I think a geologist and an astronomer needs to look at stars from an evolutionary standpoint. You need to look at the Earth as being something that was very, very different in the past. And it's very sound to look at it like that, because what we see in the night sky are large gas giant stars, astrons, very, very hot astrons, which, are called stars. And the conclusion should have been made. Maybe Earth was one of those at one point. But instead, no bridge was ever built between the geologists and the astronomers. The astronomers just kept on going on their protoplanetary disk idea, and the geologists kept on looking at the Earth as forever, never, ever, ever changing. It's always just sort of been like this for the entirety of the Earth's history. They don't look at the Earth from an evolutionary, maybe Earth was big like Neptune, and even bigger like Jupiter, and even bigger and really, really hot and undifferentiated and plasmatic like the sun, and magnificent. They don't look at it like that. They look at the Earth as just being rocks. That's it. But in order to build this bridge, we have to examine where all these assumptions continue. And of course, I'm going to whip out the Scientific American that I had, February 2016. This right here, I'll go ahead and read a little excerpt from it. It's on that same page that I read my previous talk from. It says, reshuffling the solar system. The discovery of the Kuiper belt, in turn, leads credence to the latest search for Planet X, because it helps explain how such an object might have ended up so far from the Sun that we still have not seen it. There are assumptions in there that are unspoken that I can point out very easily, but computer simulations suggest that the icy bodies of the Kuiper belt should have formed somewhere in the neighborhood Neptune now occupies. Notice rocks and minerals forming in vacuum, absent refractory material to melt the iron, absent air, and absent gravitation. How exactly do these rocks and minerals form out there in the icy reaches of outer space? They don't have an explanation for that. They don't have that connection to geology like they should. Something must have flung them much further out, or scattered them, to use the technical term, to their present positions. This observation led astronomers to theorize that a disruption took place during a chaotic period soon after the nascent planets congealed from the protoplanetary disk of gas and dust that swirled around the newborn sun. They have congealing going on, they have disruptions, they have nascent planets. Their whole philosophy is absent scientific understanding. As well, I had posted a video concerning the formation of Jupiter and the fact that it has 80% of the angular momentum of all the objects in our solar system that John Dobson had pointed out. Basically, there is no disk. No solar system forms from a disk. We're dealing with completely individual objects, and the origin of magma, to keep focused here, is not exactly an origin, but the remains of what was once a much, much different object. We're still seeing the star cooling on its interior, and the magma is escaping through the crust. It's like a very, very old, burned out star, because that's exactly what it is. It's very helpful to see articles like this to try to point out how closed-minded they are, how much they don't realize the little bubble that they're in. You can see the little bubble that these people are in. I'll go ahead and continue reading some more of it. It is easily plausible that if a super-Earth existed, it, too, could have been flung outward during this period of general mayhem. So they have this giant protoplanetary disk, and then there's chaos. That's how everything got to be the way it is. They don't realize that the things that change in the universe or in the solar system happen over very, very long periods of time, and all the objects inside of it are also changing and evolving. But I don't think they're going to mention that here. Let's see. And because super-Earths have been proved to be common among the nearly 2,000 exoplanets discovered around other stars over the past couple of decades, it is also reasonable to suppose that there could have once been one circling our own sun. That's quite comical. I mean, super-Earth is only at one stage of stellar evolution. The Earth was one of those at one point. Its thick atmosphere and oceans have dissipated from the sun, burning it away. So, in a way, we're already standing on it. The super-Earth is already evolved to the point to where it can host life. With that in mind, says Ben Bromley of the University of Utah, who collaborated with Scott Kenyon of the Harvard-Smithsonian Center for Astrophysics, quote, "We ran some of the mock-ups of what would happen to a super-Earth scattered from the region where Jupiter and Saturn are today." End quote. In most cases, they found that the super-Earth would be flung into a highly elliptical orbit, which would gradually become more and more stretched out until the planet was ejected from the solar system entirely. But if the scattering happened early enough, within about 10 million years after the formation of the planets, before the protoplanetary protoplanetary gas dissipated, Bromley says, quote, "The super-Earth could interact with the gas gravitationally and settle out in the boondocks in a more or less circular orbit." Uh-oh. So, not only do they have strange protoplanetary disks spinning about, they have no method for angular momentum loss, they completely glossed over that. And they have pinpointed exactly when the planets formed. In 0 time, I'll bet. Within about 10 million years after the formation of the planets. Do you see where that kind of philosophy is? 10 million years after the formation of the planet. They can pinpoint Earth just went and stuck together? That's completely implausible. And the fact that they allow that kind of mentality inside of this organization just shows you that they have a lot of work to do. They have a lot of work to do. And the work isn't going to be in the terms of the topic, because I'm just going to go ahead and try my best to get the topic knocked out of the park. But their work is going to be an identity crisis when they realize what they've been learning in school is bogus. Alright, hopefully that helps people out a little bit. I know the talk was a bit longer than usual, but you can see that there's a gap there between the two scientists. They don't realize the Earth is an astronomical object. So they should be studying geology as much as they do these Kuiper Belt objects. Alright, later.